Hi everyone, welcome back to the workshop, and it's test equipment upgrade time. And what we've got here is a Fluke 45 dual display multimeter. As you can see here, we've got the main display there, and I've actually enabled the second display, and it's up in the corner there. Now this particular Fluke 45 was donated by Richard. I'll put a link down below to the video that I made of all the gear and equipment and bits and pieces that Richard actually donated to my channel. Now when he originally contacted me and told me one of the items was a Fluke 45, he did say that there is a battery option in this multimeter, but he'd long since lost the actual electronic charger board that goes inside it that connects to the battery. Now there is no battery, but he did at one point have the electronic charger board. And lo and behold, when I was doing the unboxing video of everything that he'd sent me, I was rummaging through various bags and boxes and stuff like that, and I just happened on an electronic circuit board, which I didn't know at the time what it was. But when Richard saw the video, he said he almost jumped out his seat because he recognised it as being the charger board. And here it is here. It's got the bracket fitted to it and the connections that go to the battery, and this goes inside the unit here. Now he recently contacted me and asked me if I could do the battery upgrade on this Fluke 45 now that I've got this board, and I said no problem, I'll do that. In fact, I'll make a video about it. Now unfortunately I can't get a hold of the proper Fluke battery that goes inside this unit. I can only locate them in the States, and none of the sellers will actually ship to the UK. So I'm going to have to come up with my own battery that I can put inside the unit. Now it is pretty bespoke, the original battery. I'll put a photo on screen now so that you can see it. And as you can see, it's like nothing you could possibly buy. It's very, very specific, by the looks of it anyway, for this Fluke 45. So I'm going to have to come up with something else. Now the original battery was an 8 volt 2.5 amp hour lead acid battery, and I would actually like to stick with a lead acid battery so that we can retain the existing charger unit. And what I have come up with is this here. It's a lead acid battery, as you can see, 8 volt, and in actual fact it's 3.2 amp hour. So it's actually slightly higher rated than the original 2.5. However, as you can see, this one looks nothing like the one that's supposed to be fitted to the Fluke 45. So hopefully I can shoehorn this one in and possibly make my own bracket to hold it in place. So first things first, let's open up the Fluke 45, take a look inside, take a look and see how this charger board is mounted and what we can do about fitting in the new battery. So here we are inside the unit, and you can see there's quite a space here for that battery. And if I just offer up the actual charger board, it looks like it goes in like this here. I've got a couple of screws here to hold that in place there. Yep, and there's a small ribbon cable here which looks like it attaches onto here. That's obviously for charging the battery, monitoring it or whatever it needs to do, and getting the current back onto the main board there. And offering up my new battery, yes, well, it's quite a bit longer. Pushing these cables to one side there, I think it can actually go down there like that there. I think that'll work out quite well. The only problem I've got is obviously there's no room now for this circuit board to go down there, so I think I might need to relocate that there on a new bracket, possibly. And the problem will then be this ribbon cable's not long enough to go way over here, so I'm going to have to extend this or replace it somehow so that it can reach over onto the control board there, the charger board, but I think that's the way to go with a custom metal bracket there. In actual fact, I think I'll turn round the battery in this orientation there so that my metal plate doesn't come across the top of the terminals there. Yeah, so I just need to fabricate an L bracket, a new L bracket there that can come along and down and mount that charger board. And I can hold it in place with some thick gasket material, neoprene, something like that, to hold it in place there. It will sit on the bottom of the chassis at this end, but there's nothing to hold it at the other end apart from the actual case of the unit itself, and I would like to do something about that, so I might see if I can put some sort of bracket across the way there to support the bottom of the battery. And there's plenty of height, yeah, or just actually, the depth of the case is just slightly more, maybe 10mm more than the battery itself, so that should work out quite well as well. So first things first, I think I'll go away and fabricate an L bracket in the first instance to support the charger board. So there we go, some scrap 2mm aluminium plate. That'll go in there just like that there. The battery will go in under there like that, and the circuit board will mount on those 3 holes there, right there. So first things first, I think I'll assemble the circuit board onto the plate and let's see how it looks in place. And there we go, dry fit, perfect from the top side. And if I just turn it over and look at the underside, yep. And actually the bracket sits on this lip here, on this underside here. Give it a little bit of extra support there. And I've used flat topped screws there so that they don't dig into the battery too much. Although I will see if I can put some sort of material, a gasket of some sort, to space it out there. And the same with this side here. But the next thing I want to do is look at my support for the battery at this end here. Well, I think I've come up with something, so it's back to the scrap metal. I'll go and trace something out, cut it out, and I'll come back and show you what I've decided on. And here's my little bracket I've made. Now I didn't want to drill into the chassis of the meter at all, so I'm actually going to use these 2 transformer mountings there. And this plate here, little L plate here, I'll just go in there like that. A little cutout there to make room for those wires, etc. I don't want to come down on them. And enough support from the battery. So I'll go and fit this now. Well, those screws were glued in place, so quite a job to get them out. At least I got this one out anyway, and I had to break open the long screwdriver to give me enough room to get on the handle there to unscrew it. And yep, it's coming out. Rather a long screw. Well, let's see, is it going to be possible to get that in? Yes, it will. Yes, no problem. So let's try and get this one out. This one had more glue or varnish or something. And there we go, that's in place there. So I think we're ready for an assembly of sorts. At least get the battery in and secure, and then we can start looking at this ribbon cable here. And there we go, some adhesive sided neoprene gasket on both of these here, and that should clamp the battery in place. So let's just try it there, and this side here, and I've just got to squeeze the plate slightly to line up those holes. Perfect. Yep, and that's not going anywhere, and well clear these terminals here as well, and that's what it looks like from the underside. Perfect. Okay, so this ribbon cable, well, unusually this is actually just a normal ribbon cable. It's not anything heavy duty, considering that it's delivering the supply voltage to the main board there from the charger board. So I can only assume that this is actually a low current, low power meter, and it doesn't consume much at all, and this ribbon cable's fine. And I've got something that matches it here, some 10-way stuff here, so I can hopefully remove those bespoke connectors. By the looks of it, I've never seen anything like that before, like staggered pins there, and hopefully I can remove that by unclipping it and then clamping it down onto this new cable in order to lengthen it. But one thing I noticed when I was in the meter here looking at the main board, let me just zoom in on a resistor down here. I can only assume that this is a factory mod. There's a resistor here that's been snipped. It's definitely been cut by side cutters. It's a nice clean cut in order to take it out of circuit there. And that wasn't me, and I know it wasn't Richard, so well, it must be a factory mod. And there is the ribbon cable removed, and the first thing you should always do before you start taking apart an existing ribbon cable is orientate it, sketch it, and just so that you can make sure that when you put a new one together you don't reverse the actual connectors, because as you can see here, this particular one, that one's up this way and that one's down that way, if you know what I mean. So when you fold them over like that, they are actually orientated in exactly the same way. So I need to make sure I get the same orientation for the new one. Well, that's a bit of a disaster. The tops are moulded onto the tops of the little wee housings there. They're not removable, so I had to try and break it off, which I did and managed to get it off, but clamping the new ribbon onto the tops there proved to be a bit of a problem, because it just pushes the inside side of those contacts up this way into the housing, so I got no real way of clamping them back down. So I think I'm going to scrap this idea. So well, there's it lengthened, and it's not too bad. I really need to look up and see if I can get some more of these connectors here, some new ones, and maybe make up a brand new cable from scratch if I can. In the meantime, let's assemble this back together, and I've still got the crimps on the battery terminals to do yet. Okay, I think we're ready for a power up. First things first, let's just check what's in that battery. As supplied, 8.7, that should be okay. So let's plug it in, negative and positive with its new crimp. Let's just check across the battery again, and we're still getting the 8.7. So let's try for power up. Nothing, absolutely nothing. Oh, with the power switch on, let me check and see if we've got any drain in that battery at all. I'm still getting the 8.7. Nothing at all. Okay, let me put the power off. And I'll put the power switch on. And it's powering up. Let's just see if we've got any charge in that battery at all. Still got the 8.7. I think that board's doing absolutely nothing. Okay, let's take a look at the schematic, and this is for the main board on the unit here. You've got the mains AC coming in here, a couple of rectifier diodes and the main bulk cap, 4735 volts, so probably around about 25 volts or something like that. And you've got the main on-off switch here, obviously in the on position. It's going to feed right through here and power the rest of the circuit. In the off position, it looks like it's feeding power up through here to the battery board, and that'll be to charge the battery when the meter's in the off position. When the meter's in the on position with no mains AC connected, it looks like it's feeding power back down a different connection here, back to the input of the on-off switch, and then if you put it in the on position with no mains AC, it's going to feed power there. So I'm expecting you've probably got something like 25 volts coming back down from there as well, from the battery circuit. And it looks like you've got another pole on that on-off switch probably for some logic on the battery board, just to set things up correctly, depending on whether it's charging or not, or there's no AC connection, etc. So what I'd like to know first off is, with no mains AC coming in, am I getting anything across that bulk cap with the meter in the on or off position? Well, the bulk cap's on the underside, easy to get to, so I've got the meter in the off position right now. So let's just go in here and measure across that capacitor there. 0.86. And let me try it in the on position. What am I getting? 8 volts. Oh, looks like... Ah, wait a minute! I've got something on the display now! Wow! It's just come to life. Well, it wasn't doing that before. Why is that? Let me turn it off. Yep, it turned off. Let me just rotate this round. Put something underneath it. Try powering on. Yes! It's running off the battery! Wow! And what's the voltage across the battery now? 8.5. Yeah, there's life in that battery alright. Have I got a loose connection somewhere? Maybe that ribbon cable that I was Ah, yes! That's what's wrong. I've got a dodgy connection on that ribbon cable. Need to fix that. Okay, so I've re-crimped the connector at the charger end. Let's just try it now. Yep, we've got power. Let me just wiggle the... Ah, it's still dodgy. Okay, third time lucky. And we've got power. Right, I'll wiggle it again. That's better. What I did was I just used my long nose pliers to nip the grip around the ribbon cable just that little bit tighter around each one of the cores there, and yeah, it's definitely made a difference. On the other end, yeah, that's fine. Brilliant. So I guess the question now is, does the charger work? Will it charge the battery? Well, let me plug in the mains AC lead and measure across the battery with it in the off position and see what it does. Right, it's in the off position. Yes, 9.8 volts. Oh, wrong way around. 9.8 volts. That battery is charging. Brilliant. And I should be able to turn it on. Yep. 8.9 volts with the meter in the on position, AC supplied. So turn it off. So am I right in saying it only charges in the off position? Well, looks like it. So what I'm going to do now is, I'm not going to box it up just yet. I am going to leave it on charge, so it's in the off position here. So it should be charging now. 9.9 volts. I'm just going to leave it, and let's see if I can charge that battery to full capacity. Like I said earlier, I don't know what sort of charge it's got on it already. It definitely wasn't flat, that's for sure. So I'll come back when it's charged. One thing I've been looking at is the height above these terminals and the batteries in the case of the actual unit. So what I've done is I've got some really thick adhesive foam here. It's quite compressible, and I'm going to put it to hold the battery down by the actual bracket itself, and that should hold it down. Yeah, that's just the right amount of compressibility there. So let me just put the screws in, and I'm actually going to do something else as well. I don't think that battery's going anywhere actually. I mean, it's solid in there, but I've got some adhesive fabric here. It's quite thick, and I'm actually going to stick it on the inside of the housing itself right above the terminals there, just in case. Well, that's it all boxed up and the battery's fully charged, and well, all I can do now is just use it. I probably will try and run the battery right down, let's see how long it lasts, but for now I think that's enough for this video. I've got a nice little Fluke 45 battery powered that I can use when I'm out and about if a handheld multimeter is not up to the task, maybe dual display, something like that. And it's working perfectly on the battery. So thanks for watching, and remember you can always comment down below, and don't forget to like and subscribe. It really does help the channel grow. Links below to my website, and for those of you who prefer Odyssey, check out my channel there. There's plenty more repair videos on my channel, from the simple to the complex. Check them out, and thanks for watching.